center. Basically, it's the arithmetic mean of the given coordinates. Okay. So this is a simple problem of mathematics, or you can say implementation. So okay, let me just in my board. Suppose you are given xc, yc, and k. According to the question, you need to print k numbers x1, x2, up to xk, and similarly y1, y2, up to yk, such that the arithmetic mean of these x coordinates, that is x1 plus x2 plus up to xk on k, is equal to xc, that is the given center of x coordinate, given x coordinate of center, and similarly y1 plus y2 to yk upon k, that is the arithmetic mean of the given y coordinates, is equal to the y coordinate of center upon k. This is equal to yc. Screen is visible, right? Guys, please let me know, okay? Otherwise, I wouldn't know whether I'm visible or not. The board is visible, right? If all, then the point and decrement k by 1 is not, then okay, that is one approach. But I'm going to discuss another approach. That is the general approach. Okay. So just hang. The board was visible, right? Okay. So see, what we can do, you can observe one thing from this fact. Yeah. Yeah. If the average of these is xc and the average of these is yc, this is only one case, then you can observe one fact that the sum of x coordinate, that is sum of xi from 1 to k, this is your k times xc. Similarly, the sum of y coordinates 1 to k, this will equal to yc 1 to k. So this is an important fact. So what we can observe is that we need to print all the x coordinate in such a way that their sum is equal to k times xc. So this is the total sum that we need to make up from the x coordinates. And similarly, we need to print the y coordinates in such a way that their overall sum is equal to k times yc. So did you understand the result? Hello? Okay, yes. So basically, we need to print the x coordinates in such a way that the sum is k times xc and the y coordinate sum is k times yc. So suppose let us call it as x sum and y sum. That is the sum I need to make from x coordinates and y coordinates. So my x sum is k times xc and my y sum is k times of yc. So there can be several approaches as one of you suggested, but I'm giving a general idea that if I need to make the sum equal to kxc, what I can do is I can start a loop, and every time I print a number, suppose I start from xc. We are talking about x, okay? Suppose this is x, what the x that I'll print, and this is the y that I'll print. So if I print xc in the first case, so out of kxc, I have already printed xc. So my required sum will decrease. That is xs will be now xs minus equals xc, right? Because I have printed xc. So the news now that the net sum from these elements that I'll print, the next k minus 1 elements, this should be equal to xs minus xc. So what I can do is from start, I can start printing xc and reduce my sum every time by xc. And in the end, if I continue along this way, the net sum of these elements will again be equal to xs, right? Because this is xc. Now my xs is reduced by xc, again reduced by xc, again reduced by xc. In this way, the net sum of these elements will be equal to xs. Similarly for y, but see, you can't do yc as well, because if you do xc, yc, then If again I print xc and yc, these two coordinates will be same. The points will be same, but the question clearly states that the points must be distinct. It says k distinct points. So what we can do is we can print xc, 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 and keep reducing the sum. And in the last, I'll print the excess so that the sum of these elements will be equal to excess because I'm reducing the excess by xc every time and I'm printing just xc. So in the end, if I keep doing this, suppose this is my xc, again xc, again xc, this is up to k minus 1 times. And in the last, I'll just print the excess, the left excess, because every time I'm reducing here, my excess is excess minus xc. Here my excess is again excess minus 2xc because I've reduced already xc, then again reducing xc. This is excess minus 3xc. So see, in the end, if you add these numbers will excess minus 3xc. And if you add these numbers, xc, xc, xc will cancel out from these 3xc, and my next sum will be equal to xs. But if I keep on doing this for x coordinate, I can't do this for y coordinates because if I also do this for yc, these all points will be identical, right? And I'm not allowed to do so. So what I can do is I can change yc a little bit. Instead of printing, I'll print xc equal to xc. Every time I'll print x as xc, and I'll print y as yc plus some constant. Some number which is changing, not a constant. For example, if I'm iterating on a loop, I'll print this as yc plus 1, then yc plus 2, then yc plus 3, yc plus 3. And just as I was reducing xs by xc, I will reduce ys by these numbers. Okay. Is it clear? Hello? Hello? Okay, so I'm assuming it's clear. So in the end, we can summarize the entire approach and what I mean. Solution will do something like this, that I'll iterate from I equal to 1 to n. Okay. And I'll not n, k, we need k numbers, right? So I goes to 1 to 1. For the first k minus 1 numbers, I'll print xc. That's correct. I'll print xc, xc, and so on. And every time I'll keep reducing my excess. Excess will be minus equals x. Okay. And in the end, I'll print the resultant excess so that my sum, this sum, this sum will be equal to k times of xc or excess. This will be the required excess. Similarly, for y coordinates, I'll print on yc plus I. Yc plus I. I'll keep on doing this for k minus 1 times and reduce my ys minus equals to this thing that I'm adding, which is yc plus I. So that in the end, when I add this ys, so just as I was adding this excess, I will add this ys in the end, and the sum of these numbers will be equal to the ys origin, okay, and excess origin. So I guess the first rule should be clear now. If it's clear, then I'll move on to the code. Hello, is it clear? Hello. Okay, so the code is also simple. We just need to implement this approach in the code. Okay. So let me this is the code. Yeah, this is the code success. You can see we take input as xc, yc, and k. And after that, I calculate the excess. That is the sum that I need to make from x and the sum that I need to make from y as k times xc and k times yc. and then I iterate from 1 to k, from 1 to k minus 1. Okay. This loop goes from 1 to k minus 1. Just as I said, k minus 1 times I will print xc and yc plus I. Then I will reduce my xs by xc and ys by yc. Basically, I will reduce my total sum by the sum by the number that I have already added. And in the end, I get xs and ys. So this is true for the first one. So I guess there shouldn't be any doubt in the first problem. Is it fine that then I'll move on to the second problem? Hello, is it fine? Okay, so it's clear. Then let's move on to the second problem. You are given a permutation P of length n. Find a permutation Q of length n that minimizes the number of pairs I, comma j, where I in j lies between 1 and n, such that Pi plus Pi plus 1 up to Pj is equal to Qi plus Qi plus 1 up to Qj. Okay, so permutation of length n, I guess you all know what the permutation is, but still a permutation of length n is an array consisting of n distinct integers from 1 to n. So a permutation is just an array of n elements that contain the number only from 1 to n and all those numbers. Okay. So basically it means that sum of subarray 1 and sum of subarray 2 shouldn't be equal. Okay, let's come to the group. So what it says that we've been given a permutation P. Suppose P contains of these numbers as P1, P2, P3, P4, P5, and so on up to Pn. This is permutation of length n, and we need to print permutation of q of same length n. Okay, I'll denote Pn as a permutation of length n, Qn as a permutation of length n. This let's name it as P of n. So these are the n numbers in P, and we need to print a permutation q such that if this is Q1, Q2, Q3, Q4 up to Qn, let's say, then what it says that for I and j, this is talking just about an interval, okay, from I to j, from I to j. So if I take an interval, suppose this is my interval, that interval can vary from 1 to n, the length of the interval can vary. Then this interval, if I take any interval in P, then the subsequent interval in Q, it says that their sum shouldn't be equal. And I have to try to make this, I have to try to make this condition as minimum as possible. That is the sum of these elements, the sum of continuous elements, the sum of continuous subarrays in P and Q shouldn't be equal. And I have to minimize this case, that I have to minimize such subarrays in P and Q, that is their sum is not equal. Okay. So is the problem statement clear? No. Cyclic rotation. That is the approach I'll discuss. There are several more approach. In fact, in during the contest, I did something a little bit different, but actually cyclic rotation is a more obvious answer to this problem. So is the problem statement clear? Okay. So as we to say cyclic rotation. So let's discuss what it means. First of all, we need to look up at the fact that these are this suppose this is a permutation of length n. So what it means that it contains permutation of length n. It will contain all the numbers, all the natural numbers up to n, right? 1 to n. It might be in some order, they might be arranged in some random order, but it contains only the numbers from 1 to n and both inclusive. Similarly, for q of n, it will also contain the number from 1 up to n. So one thing is clear that Pn contains all the numbers from 1 to n, and Q1 also contains all the numbers from 1 to n. So if I take this interval, that is the total from I equals to 1 to n, I, if I take I equals to 1 and j equals to n, that is the interval 1 to n in both the permutation, then uh, then what's the fact? I mean, what do you observe about this interval? Can anybody say? If I take the entire interval from 1 to n, hello, some equal. Yes, some equal. Why? Because it contains all the numbers from 1 to n. This also contains 1 to n. So so sum of these numbers is actually the sum of the natural numbers from 1 to n. Similarly, for these n numbers, the sum is the sum of natural numbers up to n. So for full length, the sum is always equal. So what it means that the minimum number of subarrays will always be equal to 1, right? That is, our answer will at least be 1. Answer will always be greater than equal to 1. You can't reduce it further. You can't reduce it more than you can't reduce one less, and you can't reduce it further. The answer will always be greater than or equal to 1. So now comes the question, can we make it, I mean, in every case, is it possible to make it 1? For some case, it will always be possible, right? That you arrange it some way, you arrange P in some way, you will arrange Q in some way, such that only one subarray, that is this total length subarray, will have equal sum, and all the other subarrays will have different sum. In for some random orientation, it's always possible. But my question is it always possible? So let's see. Let's take just a small example. Let's take three numbers. Permutation E of 3. So suppose we are discussing about P of 3. P of 3, I have this representation 1, 2, and 3. And I want to design Q of 3 such that equal sum subarrays is minimized. So if I take any random orientation, suppose this is 3, 2, and 1. This is a random orientation. So sum of these three numbers will always be equal. So for interval of full length, sum is equal, of course, it's 6. Let's take the interval of 1, 1, 3 not equal. 2, 2, but it's equal. Okay, if I take I equal to j equal to 2, the length, this subinterval, this is equal. So for this case, it's not possible. But again, for this case, it's possible. So what we see that if we try, we can actually achieve it. Suppose, let's take it again. This is my permutation of size 3, 1, 2, and 3. What I can do in Q, if I take whatever the values of pi is here, these are my pi's, right? Pi, pi plus 1, and pi plus 2. If I put a value of 2 in, that's pi plus 1. This is my 2. This is my pi plus 1. Again, this will be 3. And this will be 3 plus 1, 4, right? But I can't have a value 4 because my permutation is of length 3. So what I can do is I can take a modular. So 3 modulo 3 is 0 plus 1. 4 modulo 3 is 1. So if I take this orientation, what you can see is that these numbers are not equal. So the subarray of size 1 will definitely not be equal sum because these numbers are not equal. If I take subarray of size 2, this is 1 plus 2. This is 2 plus not equal, 2 plus 3, 3 plus 1 not equal, and if I total sum subarray will always be equal, right? So if we can't reduce it, but we can keep on trying that it should remain, the answer should always remain equal to 1. So this arrangement works. So what we actually did here is, if you see, if I have any permutation of ei, ei plus 1, ei plus 2, up to en, and this is p1, p2, to pi. Okay. So suppose this is a general permutation I have, and I am talking about this interval. So suppose the length of this interval is length. The length of this interval is length. Okay. Now, if I in Q of I, I'm trying to arrange Q of I in such a way that the sum is not equal. The sum of this subinterval in Q of I is not equal to P of I. So suppose I take P of I as this is equal to my P of I plus 1, whatever the P of I was. This is P of I plus 1 plus 1. I keep on taking these elements. So sum of these numbers is suppose S. Suppose these numbers have a sum S. So what will these number have as a sum? There is one edge case, I'll discuss it later on, but first tell me, if assuming everything is looking fine, what would be the sum of those numbers? If pi, the sum of all pi's is equal to s, then what will be the sum of those qi if I have taken qi to be equal to pi plus 1? Low. Am I audible? Confused? Okay, okay, let me explain it. Suppose this is a permutation. This is my original permutation, okay? And this contains, there are some elements in qi, and I'm taking this interval and I'm designing my qi. So, and I decide to take every qi for this interval only I'm talking. I decide that my qi will be equal to pi plus 1, pi plus 1 plus 1, pi plus 2 plus 1 for this interval, and the length of this interval is length. And suppose the sum of this interval is s, the sum of original interval is s. What will be the sum of this interval? I have increased every value by 1. Is it clear now what I'm asking? If the sum of that interval in P is equal to S, then what will be the sum in Q? S plus N or S plus N? S, I'm talking about this interval, the interval of length L. If the interval is N, then it will be equal to S plus N. But for this interval, it will not be equal to S plus N, it will be equal to S plus L, right? Yes, good. So, because I've increased every value by 1, so length of the sum of this interval will be equal to S plus L. S plus length, the length, because every value is increased by 1. So you can clearly see these values are not equal, right? Why? Not equal because every qi is greater than pi, right? I have increased every value of pi and then put it in q. So generality says that this sum, this sum will always be greater than this sum. Okay, am I clear? The sum of qi will always be greater than sum of pi, isn't it? Because I have increased every value of pi. Then I've put it in qi. Okay, so it works fine. There's just one edge case, as I discussed. If my pi, if my pi is equal to n, because this is a permutation, so it will also contain a number n, and I'm increasing every value by 1, and then I'm putting in qi. If my pi is n, then increasing by 1 will make it n plus 1. But my permutation is of length n. I can't actually put n plus 1, right? So do you understand the problem? Yes, we have to make the number n 0. But we can't put 0, right? Permutation contains a number from 1 to n. What we will do is we'll take modulo of n, because n plus 1 taken modulo n will make it 1. Why? See, you can see it if qi. Okay, let me clear this one and I'll tell you. Okay. If I, in, suppose these are the numbers in pi 1, 2, 3, 4, and 5, and my consecutive qi will be 2, 3, 4, 5, and if I increase, this will be 6. So you can see qi has all the numbers except 1. Why? Because the minimum value in pi is 1. and I'm increasing every value of pi by 1. So the minimum value in qi will be 2, right? So qi will start from 2. So I don't have the value 1 in my qi. Is it clear? Because the minimum value in pi is 1 and I'm adding 1 to every value. So I'll have all the numbers from 2 to n in qi, but I will not have 1. And there is the answer. If my pi is n and I take modulo n and then add 1, this will have a value 1. My permutation is complete. Did you understand? I mean, how did we went to the solution? How did you remove the edge case? Did you understand? Yes. And there's a slight great proof as well. You can prove this as well because but I said that for these values, I said na ki it's sum and this sum is your S and this sum is your S plus N. Only when N is not present here. Because if N is present here, then only for one case, if here we have N, then here we'll have 1. Only for that case, my QI is less. Other than that, my QI is always greater than PFI. So in order for these values to be equal, L must be 0, right? L is 0 means we can't have a 0 interval. It means that you will have a number N and you will take modulo N and it should become 0. This is the proof. So if you don't understand it, don't think too much. If you give it some bit of time, you will clearly understand. Is the solution approach clear? How we design the solution and why it works? If you have any doubt, you can ask. Okay, so now it's clear. Let's move on to the code. And this is my code for the second. Now it's really small because the idea was just in the thinking part. Thinking part needed some time. So n, I took the input array. Then after that, I just printed the bag AFI module n plus 1. And it should work. It did work. I submitted this. So is there any problem in the code? I think it shouldn't be. I explained for a time. The second problem is clear, right? No doubts, right? Sonia, is it clear? Okay, that's great. So I'll be leaving now. The next portion of the meeting will be taken by Smriti. Okay?
Okay, so let's start the Atcoder discussion. So you have solved two questions. I will discuss from up to D. So I will share my screen. Am I audible? And is my screen is visible? Okay. So let's start Atcoder discussion with A. So just read out the first. The problem statement is we have given an n valid broadcast and n is odd, and there are two candidates T and A, and we want to know at the current time, like at that moment, T get 4 votes and A gets 2 votes, but there is remaining 1 vote. But we want to find out like T has won already or not. Okay, so it is easy kind of just like we want to if we want to find out T has won or not. Just what we have to do if either T or either A is get the more vote from n by 2. N is odd, then n by 2 will get we n is odd. Here is n is 7, and we will get n by 2 is 3. So strictly greater than and from 3, which will give us 4. If anybody has got 4, then the result is already decided, because if the remaining votes will vote to the A, still it will be less than from n by 2. So That is a easy approach for the A. Maybe you have understand A. What was the problem and what was my approach? A. So let's start with B. What was B? B is the problem. Like here we have given n strings from S1 to Sn, and the m is the maximum size from all of them. Okay, we need to print m strings. Like maximum size is m, and we need to print m strings. That satisfy that condition. Ki uh, each can contain lower Latin English, basically lowercase and star, but not end with star. Okay, and the problem it says like for the first string t1, what will be our first element? So for the each, for I to j of si, we will take the n minus I plus 1. Basically the given string is like that: a b c d e f g h I. So for our first string, basically here is the maximum length is 4. So we need to print 4 strings. That is clear because m is 4. Okay, then what is the statement is for the particular our jth, for the particular our ith string, for the jth character we will take out from like like this, in this way. We will take the first character this, second character this, third character this, because this will be n minus I plus 1. N is value as 3, 3 minus I on the first, basically 3 minus 1 is 2, 2 plus 1 is 3. So basically we will take this element, this and this, then fda, then geb, then here is the blank, so we will take star h star c. So basically it has given here, like if the particular string ends and we need to find a character, then there exists a star. Basically we will take out here star h star c. Now I, then here is empty star, then here is empty star, but we know the second condition is says that ti does not end with star, so we will only take I. Okay, the problem statement is clear. What we have to do? Tell me. The problem statement is clear. Okay. So what we have to do is clear. Now I will show my code and I will explain my approach. So basically, what I has done, I take out the maximum length from all of the strings length that it stores it into the MX. Okay. Then basically I have done here, I will running my loop for each string, and for the empty space, like from space, if that particular string like d is less than from 4 length, so basically I have done, it makes the length of 4. I will show, just wait, what is happening here. So basically like abc is less than from 4 length, so I have take out the 1 star at the end. D has the less than 4 length, I take out the 2 stars. fghi has less than the 4, it is equal to 4 length, so no star is at the end of this. Like in this also you can consider what we have done. This first string and third string, it is less than from the maximum length, so we will take the star at the end of the string. So this for loop is like adding the stars at the end of the string, so it is running from the loop from the at the length of the particular string to up to max of max. Okay, so this is we are doing. Then what we have to do, just taking a answer string and taking the character like this: fda, like fdageb, then h star c, like this. So basically what I have done, I am running my loop from n minus 1. N minus 1 is this, and particular to j, and I will need to maximum strings. Okay, mx strings. So basically I am doing this, adding into the my answer string. Basically it gives me output will like this. Output will look like this: a star, a b star c. Just you can consider our output will look like this. We our answer vector, our answer vector is like this: fda, which is correct; geb, which is correct; h star c, which is correct; but I star star, because here we have put it star and star. But we know that our second condition is like I can't end with the star. So basically I have modified the my string here. What I'm doing, I am doing if the my string, I will run out like I am iterating through all the strings from 0 to mx. And what I'm doing, I'm considering from the backward, from here, like I'm taking I'm considering element from here. I'm taking a string temp and running from loop n minus 1 to, because every string we know the length having n. Okay, because we are having n elements, so every string having length n. So I'm running my loop from n minus 1 to j equal to 0. If the my current string is empty, temp is equal to 0. So basically I and the particular character is star, so I will not take this element. Basically in during the contest I have done, like we can take negation of this whole, but like I have done like this: if empty and else in the, if this is not the condition, then we will take temporary into the our array. So basically what we are doing, we will not taking star star, then we will take I. In this case we will taking c star h. So just we need to reverse our string and uh, giving output like that. So I will run this loop and you can consider it is passing, and you can see it is accepted. So up to B is problem statement and code is clear. Hello. Okay. Now move on to C. What was C? C is like very easy question. You are given you have an empty bag. Okay, and the Q queries. If the first query is like one x, one is means we need to put into the our bag. Okay, two means we need to remove x from our bag if x is exist in our bag. Like remove one ball from the integer x, return on this from and discarded it. Okay, it is granted that bag has a one ball. At least if the bag has this ball, then we need to like put out from. If there is no like ball with value x, then we can't take out any ball. And third is we need to print out how many different balls are there. Okay, so in the first if you are thinking about the first approach, what will be the approach? Basically you are thinking like um, basically you are thinking like if we take a multi-set, then that this will be give me, and we can, if we have take multi-set, then we can insert the x balls, and when we are removing, then we will apply this formula and multi-set erase. And what will be our basically if name is st, then you will like doing this st dot find particular x. So this will remove your only one x, like if there are multiple x. But how you will find the number of different number of different balls, like which has a different integer on that. So it is like you can consider a map. Okay, We'll take a map. Map is considering how many balls of the integer x. So uh, you are taking q queries, and while like you are taking n queries, and n minus minus taking integer x. If as equal to 1, then we will take a y. Basically we are putting mp plus plus. Mp is the map, and I am just adding the frequency of map. Okay, then if my the basically query is second, x equal to 2, then what I am doing, I am doing mp minus. Basically I am reducing the frequency of that. If I'm reducing the frequency and there is no ball, then the frequency will be negative. Or if there will be one ball, then the frequency equal to 0. If in both case I need to erase from the my map, I will need to erase y from the my map. So I will doing that. If the my frequency is less than 0 or equal to 0, I will remove from map. Then the third, if x equal to 3, it means third query, and third query wants how many different balls. So the different ball you can find out from the size of map. Basically, map is storing, like taking first case, map storing 1 is 3, like map storing 3 as 1, frequency 1. Then 1 comma 1, like 1's frequency 1. Then like in the sorted order, but I'm writing like that. Then 4 and 1. Okay. Then 3. 3 is basically we need to find out the size of map. Size of map is 3. Then 2 is 1. Basically 2 1 means we need to remove 1. Its frequency reducing with 0. So we know this by this condition we will erase this from map. Then what we are taking, 3. 3 means the size of map. Size of map is 2. Then 5. So basically we are inserting 5. So that is the approach. That's how it is working. And like this is our code. I will submit. And you can say this is accepted. Like the problem statement and the approach is clear. Huh? Problem statement is clear and the approach is clear. Hello, am I audible? Okay. If you're having any doubt, you can ask. Like we will move for D. What was the D? D is basically we are giving a integer a x y z, basically 3D kind of thing, and the triplet integer x y z from this, and we are asking the q queries. And what is the query? Basically we need to find out the value, like the sum from a z equal to lzi. Basically this is our input, and we need to find out from lzi to rzi. So what is the problem statement it says, like consider here what is the uh, what was the problem asked. Just I will tell you here. So this was our input. In the 3D you can you can think like that. This is a one 2D, and this is one 2D array. These are two different 2D arrays. Okay, because the size is 2, so there are two size of basically two 2D arrays of size 2 cross 2. So 2 cross 2 size of two 2D arrays. Okay, and our first query is like first index from the z. Okay, first index, what was our first index? This is our first. Then second element. Okay, second element ka first index is 3, from 1 to 2 for the first the 2D array, and for the second 2D array we need to find out the sum. So basically sum of 3 and sum of 7. That was asked. In the second query, what we need to find out? 1 comma 2, 1 comma 2. Basically, from 1 to 2, 1 to 2, 1 to 2. Whole thing. मतलब whole sub array from 2 comma 2. 2 comma 2 is basically only the second 2D array. So basically sum of this all element 5, 6, 7, 8, which will be equal to 26. Okay. So is the problem statement is clear. How the problem statement asks matlab like queries and okay. If the problem statement is clear, then like we will, if you know, maybe you know, ki like how we can find out the um, basically prefix sum of 2D array. Do you know that? Like there is only one participant, so you can tell. Do you know how we can find out prefix sum of 2D array? If you have done the like that problem, otherwise I will explain. Do you know that? Like if I am giving you a 2D array like that, one, two, mm, basically one, two, three, 4, 5, 6. Huh. Find a prefix of rows and then column. Okay, like 7, 8, 9. Basically, what we are doing, we are adding this like then prefix of columns. Yeah, correct. So if this is a 2D array given, then we will doing the like row wise then column wise, or you can do like also that like first column wise then row wise. Both are correct. And when we are finding a query, then what we have done, basically, if we want to ask from this segment like 5, 6, 8, 9, then we will might reduce 147, 1, 2, 3, and adding one. Maybe this approach you know. Okay, so that thing I have done for 3D. Nothing is different. First, I am adding the columns. Like first, I am taking the input of 3D vector. Okay, and I am assigning my prefix as prefix vector as a sum, and the sum storing basically first the addition of columns. You can consider like it is starting from one. So I'm just taking the from column wise like one, two, three, then the row wise. This up to this is for 2D. Up to this is for 2D. And now just I'm adding every my 2D segment to our row wise 3D segment. Like this is adding my every 2D segment to 3D segment. You can see the what is the like final output. I will show you what is the final output. Hmm. So just see, is this one is added into 2, 3, and this is added into this 7. Then we are adding the column wise. So this is just giving us a 2D prefix sum. Okay, the 2D prefix sum. Maybe you know this. Now what I have done, basically I have calculated 2D prefix sum for this also 5, 6, 7, 8. Then I am summing like by the first 2D array into the second 2D array. So 1 is added to 5. This will be gives us 6. Then what is the array? 11 into 5 plus 6 is 11, and I have added 3 here, which was here. It gives us 14. Same like we are doing this. So I am just adding like into the 3D. First I have calculated 2D sum, then just calculating the 3D like every row wise. First row into the second, second into the third, then third into the fourth. Like row wise, I am calculating the prefix into the 3D. Okay, this part is clear. Like up to this is clear, then you can understand the next. And if this is not clear, then you can't understand. So tell me, up to this is clear. Okay. If this is clear, so I basically there is nothing matlab like different you need to think out. Just consider I have taken like 6 inputs which we need to take out like this. Yeah. This was our input LXI, RXI, yeah, like 6. So I have taken a vector and taking an input of vector, reducing all of this by 1. Okay. Then what I have to do? I am calculating the value is my answer. Okay. The value is my answer. I am calculating the my value up to the 135. 135 means like In the 2D, what we have done, considering like for the particular last of my 2D array, one is basically one is basically what is a D1? D1 is show my Rx up to Rxi. What is the my value I am calculating for this up to Rxi? What is the value of my this? Okay, so I am taking D of one, basically my Rxi, taking the whole segment 3 and 5, which is my Ly and Ry. What I need to subtract? We know that into the 2D prefix, we need to subtract like that. We need to, if we want to find out from 5, 6, 8, 9 sum, just we need to remove 1, 4, 7. So you can consider if D4 is my not 0. So what I'm doing, I'm taking my row number is same and column number reducing by 1. So basically I am subtracting this 1, 2, 3. This segment I have subtracted, and after that what I need to do, taking D2. Basically if this is not my first column, then I will remove this 147. 147, these elements I will remove, and both are not 0. Then what I will add, because I have removed this one two times, 147, 123, I need to add this one. So this segment I need to add. So this is a basic 2D sum approach. Okay, you are calculating for the first 2D, the last 2D, last 2D array. This part is clear, or I need to like re-explain or tell again? Is this clear or not clear? You can tell. I will explain again. Hello, am I audible? Alex, why? Then subtracting. Yeah, if you are considering the one base indexing, maybe like this is correct. Mm-hmm. Just I have done also this. Like I am considering the zero based indexing, so I need to put out this if conditions if this is not zero and this is not zero, and after that your approach is correct. I am considering if the my first like my Alex is not zero, then I will do for the same thing. This three statement is same here. I just copy paste this three statement as it is, thus replacing the d1 by d0 minus 1. This is the difference, and nothing is different between this and this. Okay. Yeah, this is correct. Now maybe like there is some little bit problem. We are adding three times. I don't know like why you are taking three times additions and four times subtraction. Maybe there will be. Correct, correct. Basically, for this is from negative, so you need to two times addition here, one time addition here. Then it is correct. Okay, the same approach. You and like this, you can take out the prefix sum from of the 3D array, and this is passed. I will understand. Your approach was also correct. If you have submitted and this that was accepted, then your approach was also correct. Hello, like this is accepted quite well. Okay, like this implementation is clear what I have done. First, I'm taking the 2D prefix sum, and uh, row wise 3D prefix sum, only row wise. And when I'm subtracting, I'm doing same thing. I'm taking the 2D prefix sum for the my Rx, and I'm taking the 2D prefix sum of my Lx, and just I'm subtracting this from Rx to minus Lx. Just same thing. Like Lx minus 1, sorry. Prefix sum Lx minus 1. Just I'm subtracting this. So this is clear what I have done in this implementation. Is this clear or not? Okay. Tell me your like doubt where you have confused or I need to explain full code again. What I need to do. Last part. Okay. So up to this is clear. Like what I have done. Basically, I have taken the 2D prefix sum here in this two loops and taking the row wise 3D prefix sum. Only row wise. Like um, the 2D prefix sum of this will look like 1, 3, and 4 and 10. Okay, this is clear. And the same thing for this. Here, what will be 5, 11, like 5, 11, then 12, 26. Okay, so this will be the prefix. And what I have done in my third loop, I have just adding this whole element into this. So basically row wise, like 1 is added with 5, 3 is added with 11, 4 is added with 12, 10 is added with this. When I need to calculate only for this, basically I will subtract this. Just simple thing. I will subtract this element. And how I will subtract? Just calculating the how many rows and columns I need to subtract. So you know the how to calculate the sum for 2D 2D. So this is the approach I have calculated for Rx. Rx is same. Like they go D1, 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 D1. D1 is basically my Rx. And I have calculated 2D. Like you have this has you written, I have implemented here. Basically adding this sum of Rx, Ry, and Rz. This is 1, 2, 3, and then subtracting this, then subtracting this, then subtracting this, then subtracting this. Then what I need to do? Addition of my Lx, Ly, and Lz. Okay, remaining part. This I have done. Then I have calculated what I have calculated for the Lx minus one. But like you are little bit wrong here. Like you need to when you are subtracting that thing, then you need to minus one, not exactly Lx. You are adding like here na Lx and Lx. So you don't need to like write direct Lx. You need to subtract Lx minus one into the prefix sum. You know me, but we are basically taking prefix, so we need to minus Lx minus 1. So I'm taking here d0 minus 1, d0 minus 1, and same thing. Like second segment is same. What I need to do for the 2D array, it is same. Just I am taking d0 minus 1, d0 minus 1, and the sign is different because I'm subtracting this. So I am adding this, so I am subtracting here. I am subtracting here, addition, addition, and subtraction. Now this is clear what I have done. It is clear. No. So that was my approach. If you are having any doubts regarding any question, you can ask into the group or like your mentorship group, and I will end this meeting here. If you have any doubt, you can ask, or like you can leave.